So I'm going to be building this circuit, if I can get it. It's a headphone amplifier that runs off 12 volts based on the 12AU7 Focus. Good enough. Whatever, I'll post a link to it in the description. So it runs off 12 volts. I have it breadboarded here. Alright, so this is it running on the scope. I've just got it connected to a 500 hertz test from my phone. If I turn the volume up, that happens. So just kind of fix that there. Oh, there we go. So that is the output from the tube. It has a gain of 2. I will put the scope over the input. Oh, my ground fell out. So let's fix that. Pardon my my bootlegged testing methods. Alright, so this is the input. It reads that, and now if I move the input, and if I move the scope over to the output, you will see that. That's weird. That is really weird. Oh, I feel dumb. Disconnecting the entire input altogether. There we go. So that's the output. That's the input. It is set at, if I can get it back on here, it is set at 0.2 volts per block, and you've got 1, 2, 3, 4. So that's about 1 volt peak to peak. Probably just made a fool of myself if I did that math wrong. Oh, my test is over. So that's what Black Sabbath looks like on an oscilloscope. Anyways, so let me put that. I'll start putting it in a box, and yeah. So this is the box I'm going to be using, just to clear. I'm pretty sure it was a headphone box or something, but I'm going to have the voltage reader to read the 18650 pack here, because you know it's going to be portable. Want that portability-ness. So went down to your favorite corporation, got some parts. I'll put a bill of materials in the description. I'm not going to go through drilling all the holes and stuff, just because it's pretty lame. So yeah. So this is the parts all laid out on the board. I would really rather do this on terminal strips, but on account of the semiconductors, I should probably use a board. Also, I would say sorry about the Empire of Dirt, but I'm pretty sure the Canadian has that trademarked, so not going to say that. These aren't soldered in yet. I will come back when they are soldered in. Just laying it out. Now what you should always do is just tack them down onto the board. Just solder one pin and then press it down and fit it, and then check everything, because electronics components have a very tendency to not care about your feelings. So if you did it right the first time, you probably didn't. Just a thought. I should probably mention, I don't know if I'm going to post a picture of this or do an easy EDA drawing on when I post the link. I don't know yet, but in this drawing, the input filter cap is a 2.2 microfarad film. I'm using a 4.7 electrolytic just because I didn't have any 2.2 microfarad. That's about the only changes I made to this circuit. I'll go through what all the components do later. So I've got one channel done. Yeah, I forgot to mention I was only testing one channel, but it's kind of self-explanatory. So one channel is going to go on this side, one is going to go here, and I've got everything soldered up except for the tube socket. I'm going to do that last. And I also somehow need to fit a 5-volt regulator, like here, what for the voltage reader. So I've got everything soldered. I did forget that I don't have a 7805, but that's okay. I'll get one tomorrow. I'm not extremely good at soldering, but you know, I get the job done. All I gotta do is connect the octopus now. So the capacitors kind of did me dirty when I went to go fit it. So I think I'm gonna drill a hole for the caps or find another box. I don't know. I knew this was gonna happen eventually. So pretty much, you move solid core wire too much, it snaps. It snapped off this terminal right here. So just, it always happens. Happens every single time. Alright, I'm gonna go test it now. So I can get the cord somewhere with my aux cord. Oh, here it is. Yeah. Oh, I got this part out. Okay, I'm gonna test it now. Have that hooked up to the O-scope. Plug in our Black Sabbath. And alright, that's cool. That is what Electric Funeral looks like. Let's see if I could pull up my 500 hertz wave. That would be a lot better. Okay, here is the 500 hertz wave. That's on one input. We will bridge the inputs. Nope, don't like that. Okay, I got the inputs bridged now, so we put the O-scope to the other channel. And oh, you don't like that? No? Well, why not? Why don't you like that? Okay, this is weird. No? Yeah? Alright, as expected, something went wrong. Because it's impossible to do something right the first time. So, there was two problems. I had the cathode of the other channel disconnected, and I had the input cap shorted. I fixed both of them, and I'm still not getting anything. There's a little signal, but it's not, it looks like it's just passing through the tube ambiently or whatever. The tube is not amplifying, but the other channel works fine. Like if I switch over, the other channel works fine until the you know, the test stops. So yeah, I will have to figure that out. So after 2+ hours of debugging, I have come to the conclusion that it is a heater problem. That's really all I know. One heater is working and one is not. So I'm gonna have to ask the forum, see what they say, maybe go back to this tomorrow. So I figured out it is definitely the heaters in the tube, but it's a problem heating the tube because I put in a 12AX7. It was having the same problem, only one channel worked, and only one heater glows when this is on. So I'm going to probably either wire these filaments in parallel or find another way to give them the 12 volts. I don't know. I have to do a little bit more testing. I also burnt a set of jumper cables, but that's okay. Okay, well the problem is not with the heaters. So I'm just going to unsolder that whole not working channel and resolder it. Because that's how long I've been testing this. Okay, after only 2 days of debugging, it works. I had The cathode capacitor bypassed. I think that's what it was. I don't know. There was a problem in this area with the cathode cap and the input impedance resistor. Whatever. So both channels work. I did test them on the oscope, but you all know what a 500 hertz wave looks like. So I will start putting it in the box. So it has come to my attention, she no gonna fit. And then like this plus the standoffs I was gonna use, it's just not happening. So I'm gonna find another box. Sometimes you find something and you think it's gonna work, and you try so hard, but you don't succeed. I don't know, maybe I'll just live with that. But I really don't like the way that presses into the out caps like that. Unless I drilled a hole for them. You know what? Society is too much about covering up. Who needs a case? I am an independent Canadian man. I'm actually American. But I don't need a case. So there you go. This is what I'm doing. Just gotta mount everything else. So the plastic cracked a bit when I was drilling it, but you know, I'll be the only one using it, so not too worried about it. If I really want to, I'll just, I don't know, I can make an aluminum chassis, but for a quick project like this, not really a big deal. Wow, I bought the wrong jack. It just doesn't work. Why? Okay, guess we'll finish this tomorrow. Okay, it has now been 2 days. I have the proper jacks. Now I just got to install them. So, you know, I'm going to be getting my soldering certificate soon. I have to do crappy solder jobs like this before I get that. Because otherwise, what's the point of being a teenager? Okay, so I got the jacks wired up. And I was actually expecting, when I plugged in my headphones, for the signal to just drop to like negative 5,000. But because I thought the impedance of the headphones wouldn't match these output impedance resistors actually, but it actually works pretty well, so I'm not gonna touch it because that's usually when it stops working. So all I gotta do is somehow cram it in here, and then I should be all set. After multiple failures to engineers, including but not limited to these cracks, spatial issues, and hole drilling, I decided I would go with the original case because I had nowhere to mount these on this one, this one right here, and also these mounting holes, the output caps are just too close, and the screws don't screw. So I've only got 2 standoffs working. Also, be proud of your bad solder jobs, because one day, when you're in millions of dollars of debt from your great engineering college and you have a minimum wage job, you'll look back on this and say, man, I should have played baseball while I was doing this. Side note, I ran out of the correct colored wires about roughly before I started this, so wire is expensive, bro. Don't judge my wiring colors. It can be whatever color it wants to be. Whatever color it identifies as. So all I gotta do is mount this stuff probably here, along with this stuff and this thing, what for keeping the juices, and I completely forgot what I was gonna say. So yeah, that's about that. So it's done. This is it. Can't really bring this on the public bus on account of looking like a clock. So got your little power switch. So you got, this is your input, this is your output, your phone, your headphones. So I'm going to break down this circuit And so pretty much, okay, for whatever reason it just stopped recording. So you got your left in, and then you're also your right in. So this is one side, this is the other side. They're exactly the same. So I'll go through one side, then you just make it twice for 2 channels. So this capacitor can be, I've seen these as low as the 0.22 microfarads. This recommended is 2.2 microfarads. I used a 4.7. That just blocks any DC from this side of the circuit going back to your phone, and it only lets the signal go through. So then you have this resistor, which sets the impedance so that the signal can go to the tube. I can do another video on the basics if you guys want. So then now the signal then goes to the grid, which then this sets the gain of the tube on the cathode, and then the signal boils up, and then it goes to the plate, which then goes to the MOSFET. This resistor just drops the signal down, the DC down, the 12 volts down, so that the tube can use it. And then the signal goes through into the IRF, whatever you're using, the MOSFET, which is also running 12 volts. And then this 317, this is really weird, I've never seen this before. This configuration actually has to do with the setting the current for this MOSFET. I thought that was pretty cool. So this just goes to ground, and then this again filters out any DC that's on this side, so only your signal's going through, and then this goes to your headphones, and then this matches the impedance of your headphones. So it's really simple. You don't really need a lot of parts. I built this. The only things I really had to buy was this LED, this switch. But that's because I go to a technical school. So if you were to, and I bought this tube. The tube was $15 at a store near me. So I think you could probably build this for under $20. Not counting getting the 18650s, but the battery holder is pretty cheap. So this is a cool little project. I had a lot of fun doing it, and it works. It does its job. If I were to do this differently, I would definitely put more time into the case, obviously, so I could, because I like my things, I like to be able to smack it against a car and it still be okay. I can do another video on my ammunition can speakers. But anyways, I would want to do the case differently. I want to add some way of charging these. I might wire these batteries in parallel so that it's 3.7 volts, and then make a boost converter so that it takes the 3.7 volts and puts it up to 12 volts. That way I can use a micro USB to charge these, and I could get more battery life and I'd be able to add more cells so I could get more battery life. Right now this circuit draws about 500 milliamps. So using these salvaged 18650 cells I took out of laptop batteries, that's about, I'd say, 45 minutes of use. I did manage to kill it today when I was using it at school, rocking out to my my Black Sabbath. It sounds pretty good. If you want to mess with the sound, these input caps, so the camera, for whatever reason, stopped recording again. So and I didn't realize it until I was editing this. So I'm recording in my room now. So as I was saying, if you wanted to change the sound of this, mess with the values of, I don't know if you can see it, the lighting is horrible. There we go. Mess with the values of the input filter cap and the output filter cap. I've seen these values be at like as low as 0.22 microfarads and as high as 10 microfarads. I know 0.22 microfarads is wicked tinny. There's like no bass at all. I don't know how 10 mic would sound. I guess you'd have to try it yourself. It's all about preference, these two caps, and really you could go as far as to mess around with
the MOSFET you use, or I would mess around with the gain. You could maybe touch the voltage, see what that does. I don't know, experiment around with it, see what you can get out of it. You could add a dual gain potentiometer. Use 100K on the outputs or the inputs, if that's what you want, for a volume. So that's about it. If you have any ideas for videos and stuff, please let me know. I will do them. I don't know how often I'll be able to get out videos, considering I'm going to be working 2 jobs soon, and I got the school, and you know, and I got a guitar. Like, you can't, gotta spend at least an hour a day on guitar, at least. So, yeah, thanks for watching.